Hey guys, and welcome back to the second part of our digital lesson that we have today. So we are going to cover array tables. Now, array tables and tree diagrams are really similar to each other. However, array tables are actually more similar to a two-way table. We can actually see a two-way table here, but instead of listing the probabilities, it's listing those outcomes. So similar in the tree diagram. So when we had our tree diagram, I'll just do a quick one here. So you have heads, tails, heads, tails, heads, tails. We know that that outcome section would have all of those probabilities listed out. If you look here, this is actually the same thing that we've done here. So that first throw is represented by this line here. The second throw is represented by this column here. And you can see all of our outcomes in the middle here. Look at this. So this can be great, particularly when we have a lot of information. So if you remember back to that tree diagram one, example one had so many outcomes. It would have been, sorry guys, would have been a lot easier for us to actually do an array table. Would have displayed that information. The only downside to an array table is you can only have two events occurring. Whereas in a tree diagram, you can branch out forever and ever and ever. Now, it is important to note as well that in these array tables is that we might have some boxes that are blank. So if, for example, maybe we had a deck of cards and we removed a card and didn't put it back in the pile, that means that that particular number would no longer be available in the second trial. So if you see any gaps here, and that's what this comment at the bottom here is talking about here, you'll see that there might be some gaps. But let's have a go at doing some examples of these because you'll see that they are a little bit bigger than the example that is here. Here we have our first example, where we're rolling two dice, one after the other. Now, if we were to draw this as a tree diagram, it would get very big very quickly because there are 36 outcomes. One thing that's really important to note with not tree diagrams, array tables, is where you need to start. So it's very important that this is our first dice that we roll. So that means that all of these, so this column in particular, they are all going to start with a 1 because that's what I'm rolling first. These are all going to start with a 2. These are all going to start with a 3. These are all going to start with a 4 and so on and so forth. Now you'll notice they have brackets around their answers. I'm not too stressed about the brackets. I am stressed about the comma between them. I need to know that they are two separate things. So once I've done my first, I can now move on to my seconds. So let's have a go at this. So this is all going to be comma 1, comma 1, comma 1, comma 1, comma 2, comma 2. And we continue. I do find this the easiest way to do it. If you have a better way of doing it, please feel free. I just find that this makes sure that I haven't made any mistakes. 5, 5, and you'll notice I am doing my comma every time. 6, 6, 6, 6. Done. Let's have a look here. The total number of outcomes, I actually gave that away before, but you just count all of the boxes. So there were 36 total outcomes. Now it's time to find the probabilities. Once we know the total outcomes, all these probabilities will just be the amount of times that I can see the numbers or it fits the criteria of our outcome over 36. So let's have a look. Find the probability, so probability, PR, that my outcome is 1, 1. How many times does that occur? Only once. So that means my probability is going to be 1 over 36. The probability that I have a double. So when we say double, we mean that we've got the same number. So 1, 1, 2, 2, 3, 3, 4, 4. Let's have a look. I've got 1, 2. Conveniently, they all go down the diagonal. I've highlighted 6 numbers. There was a total of 36. You can simplify that fraction, but again, I'm not testing you on if you can simplify fractions. I'm testing you on whether you can find that probability. Let's have a go at this third one here. So the probability that I get a 3, 1, a 2, 2, or a 1, 3. Let's see, there's only 3 options that align with that. So 3, 1, 2, 2, 1, 3. I highlighted 3 numbers out of 36. The last one here, the probability of having a 1 or a 6. Again, trusty highlighter, get that out. I can see all of these options have a 1 in them. All of these options have a 1 in them. All of these have a 6, and so will these. So I'm going to have 6, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I have 20 out of 36. I do find array tables a little bit easier than tree diagrams because the information is a lot clearer, but very easy to see the connection between the two of them. Let's try a second example. Second question here. Some of these questions are straightforward, but the last part here is a bit more of an extension question. So I'll leave that as a bit of a challenge if anyone wants to try to give it a go. So this one here, first thing we want to do is complete the table. We'll worry about the money stuff in a minute. Now the first thing that I want to recognize straight away is where that first spin is starting. So I know that I'm going to go down my column with the same number, 3, 3, 3, 4, 4, 4, 4, 4. Now I can look at that second spin. So let's add in the rest, making sure that I have a comma. I know that this is very time consuming. I do apologize. It's because we have so many things happening at once. All right, table is filled in. Tick. Let's have a look at what those conditions actually were. For $1, you can spin a spinner numbered 1 to 5 twice. If you spin 2 even numbers, you receive $2. If you spin 2 odd numbers, you get your dollar back. Otherwise, you lose your dollar. So that means that to lose your dollar, you need to have an odd and an even number. So the probability of losing your money, we want to look at all of the odd and even combinations. So this one here, 1, 1 is both odd, 2, 1 is odd and even, odd and even, odd and even, odd and even, odd and even. You will find there's a bit of a pattern to this one. So these are all of my odd and even responses. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 out of 25 possible spins that I'm going to lose all of my money. Let's have a look at the next part here. What is the probability of making a dollar profit? So that dollar profit was with two even numbers. So let's have a look here. 2, 2, 2, 4, 4, 2, and 4, 4. I can see why they now did this. So the probability of winning is 4 over 25. Here's an expected number question. In 50 attempts, how many times would you expect to lose your dollar? So to figure that out, what we're going to do is we are going to take 50 and multiply that by 12 over 25. And that is going to tell us the expected amount of times that we are going to lose our dollar. And I got 24 times. Now again with that last question, you will need to do a little bit more maths on that, so I'm going to leave it as a bit of a challenge question. But as you can see here, array tables are pretty straightforward. They always have an even chance of occurring, so there's no biases, there's no rigged color schemes or rigged dice. So they are pretty straightforward. Those tree diagrams is where we do get a lot of those changes, which is why I recommended doing those questions last. But hopefully this has given you a really good understanding of array tables, and if you have any questions, please reach out. Thank you.